Hello students, I hope you have seen my current electricity part 1 lecture and have gone through all the points, revised them thoroughly. In today's class, I will first start the revision of the previous concept with the images. Just carefully read the image, and if you are not able to understand in the given time, you can pause when the image is there. Yes, and if there is any doubt related to it, do send me a message. And all of you take out your books and pencil in your hand to underline the important points. We will start with the concept of direct current. In the previous class, I told you that primary cell are able to give us the direct current, that is the fixed amount of current, and the cell can convert chemical energy into electrical energy. Yes, now we will look at the diagram of this cell and we will carefully observe these points. What points you have to keep in your mind? Where are the electrodes, that is the positive and the electric electrode? What is the direction of the current and what is the overall structure of the current? In that diagram you will see that there is a electrode inside the cell. That electrode acts like a positive electrode. After that, we had talked about primary cells and secondary cell, how they are different from each other. Primary cells can't be recharged. They are kind of irreversible substances, whereas secondary cells can be recharged, and the reaction which take place in them is reversible reaction. Then we came to the main concept of the chapter, that is electric current. Now, in electric current, we talked about the direction of electron flow and the current direction, that they are going to be opposite to each other. Now, I'm going to show you an image where all the important points are given to it. Just go through that slide and read the points again and again carefully. Pause the video so that you can read it comfortably, and if any doubt, just ask me. Now let us relate this concept to the image where you will observe that the electron flow direction is opposite to the conventional current direction. And below concept we have already covered in the previous slide. Yes? Now all of you come to the topic given on page number 188, symbols used in the circuit diagram. Before we go to the symbol, the concept of source of current is there. We have already discussed about one source. Which was that one source? Direct current. Yes, DC. But now we will first start our discussion with alternating current, that is AC. Now, definition of AC is given in the book in this red color sentence. All of you underline the sentence. This is not very clearly visible in my book. So read in your, not very clearly visible in the image. So all of you read through your book. Now here it is written, an alternating current, AC short form, is the current in an element for which both the magnitude and the direction change with the time. So AC, as the word says, alternating. Alternating means changing. One time the current is flowing from left to right. In the another half revolution, it will be traveling from right to left. So the movement of the current keep on changing, and it is denoted by a simple curved wave, which I will show you in the next image. Now what else is given? The current repeats its value after a fixed time. Now, although we are saying that the current direction is changing, but it doesn't mean that the magnitude or the value of the current changes. At a particular time, whatever is the value above the x-axis, the same value will be below the axis after the same time interval. But we will not go into the detail of it. The number of times the current repeats its value in 1 second is called the frequency of alternating current. You must have heard about that in India the frequency is 50 Hertz and in US the frequency is 110 Hertz. It means that in 1 second the current direction, that is from positive to negative, changes 50 times in that 1 second. Yes. Now let us look at the difference between DC and the AC circuit. In the DC circuit, you will observe that the current is flowing from positive to negative direction, and that is single one path flow of current is there. Whereas in the alternating current, a wave-like structure is shown, which means that the current direction is changing. One time it is from top to bottom, in another half cycle it will be from bottom to top. I hope the concept of AC and DC is clear to all of you. Now all of you come to the page number 188, where we are talking about DC source, that is cell. We all know that cell is represented by a big line, that is the positive line, and the smaller line, that is the negative line. Yes. Now if I want to make a battery with the cell, what I have to do? I am going to connect these cells in series. In series means if I am starting from positive, negative comes. Again, for the next cell, positive will come first and then the negative. You can't change the order of positive and negative. So, cells are connected in series to make a battery. How they are connected? Positive, negative, positive, negative, positive, negative. What does it mean? It means that negative of the first cell is connected to the positive of second cell, and then the negative of the second cell is connected to the positive of the third cell. Yes, and this is how we will make a symbol for a battery. So cell is a source of converting chemical energy into electrical energy. And battery, how you are going to define battery? Battery is a combination of cell. And when it comes to the AC source, and here this wave sign is shown here. Yes. Now here are few important points. Underline this. When a strong current is needed, means if you have small cells, for example, one cell give you 1 ampere, but you want 5 amperes current in your circuit. So what you will do? You will take 1 ampere, you will take 5 cells of 1 ampere. And how you will join them? You will join them in series. So either we join the number of cells together in series. So once we join in series, we get more voltage, we get more current. So how we have to join? We join cathode of one cell to the anode of another cell. Means cathode means positive. So positive is joined to the negative of the next cell. And this is how we form a battery, or we use a storage cell. Yes? In the next image, you will see that three cells are connected, and when they are connected in series, the voltage increases. Yes, the three cells, the one cell is of 2 volt, and three cell together becomes 2 plus 2 plus 2, 6 volt battery is formed. 6 volt means more current can be drawn using these three cells. Yes, so if you want to increase the power, you want more current in the circuit, but you have small cells with you, how you will join them? You will join them in series to make a big battery, and you can draw more current from those cells. Before we go ahead, let us recall the two terms insulator and conductor. All of you come to the page number 191. Here the term insulator and conductor difference is given. Now let us underline the important points. The substance which do not allow current to flow through them are called insulators. They have no free electrons. Children, whenever we have free charges, wherever we have free electrons, then only the current can flow. We have studied this in our part 1, that current is due to the flow of charges. So if there are no free charges, there are no charges moving in an insulator, how it will conduct a current? So this is one definition will become one point of difference. This is the second point of difference. The third point, it offers a very high resistance to the flow of current. Insulators does not allow flow of charges, means they obstruct the motion of electron. Obstruction can also be termed as resistance, like they are resisting the flow of current. Yes, and here we have the few examples for insulators. Similarly, let us underline for conductor. The substances which allow current to flow through them easily are called conductors. And what materials will come under conductor category? Metals like copper, aluminium. Why they are conductor? Why they are able to allow the current to pass through them? Because they have large number of free electrons in them, and when their path is smooth, there is no obstruction. What do we say? There is no resistance. So a very small resistance is offered to the flow of current. Now here I have underlined another important word, that is human body. Question may be asked in the exam, is human body a conductor or an insulator? So what do we say? We will say human body is a conductor. Why it is a conductor? We are conductor because we allow the current to pass through it. Now you will think, you may ask this, how we are able to pass current through us? You know that in our body there are many salts, and those salts, due to the chemical reactions, they divide them, they dissociate themselves into ions. So those free ions help in the conduction of electricity through our body. So I hope now this point is clear to you, that why we considered a human body a conductor. What is the reason behind that we act like a good conductor? Yes. Now next important point, impure water and mercury are also conductor of electricity. When we say impure water contains many salts in them, and those salts dissociate to form ions, and therefore it acts like a good conductor. Now in the next slide, I am going to show you the difference between insulator and conductor, and you will note down those points and learn them. Now, children, we will come to the topic symbols for circuit diagrams. Before we make a proper circuit, you should learn the symbol for the devices and what is their use. In the next slide, you will see the symbol of a cell or a battery, what is their purpose, the symbol of the rheostat, ammeter, voltmeter, yes, and a key, and what is their use. So make that table in your register also. I hope the symbols are clear to you now. And student, I will be giving you few questions. Sometimes I will say you to do from 10 to 20. Okay. So for instance, in 10 to 20 questions, few questions answer are given in the book itself. You will not do those questions in the registers. Yes, I don't want to discontinue the series of questions. So I will be telling you to do 10 to 20 questions, say instance, but you will skip those questions whose answers are given in the book. So we will be doing only those questions which have whosoever answer we are looking into the book and they are given inside the book, not with the question in the back exercise. I hope my point is clear to all of you. So along with this slide, I will be giving you few questions and skip those questions whosoever answer is there in the back side with the question. Thank you for today.